Okay, so I think we are ready to like really enter binomial theorem. Okay, and to kickstart, we are going to address our motivation for this chapter, which is to really expand a plus b to the power of n. All right, so I'm going to split this into two videos. I'm going to do the first video, which is the exploration part, which is like how do we discover the formula, or how do we really expand? How does the expansion look like? Okay, and the second part of 6.2, I will address the application part. Like when we are given a certain things, then how do we, like how do we, what do you call this? Like how do we like solve problems, right? When we come to it. Okay, so with this in mind, all right, I'm going to start off with just the basic a plus b, right? So a plus b, right, to the power of 1 is going to be a bit boring. So it's just a plus b. Okay, but let's raise it a bit to what we've done before. So this is a plus b square, right? And we've learned in sec 2 that a plus b square is this what do you call it, is this identity where we have the a square, right, plus 2 times a times b plus b square. Okay, so this is a plus b square, right? The results that we've learned so far. Okay, so the question in that the main question that we're trying to answer in this question is, what about the higher powers? How do they look like? So let's explore a bit. I'm going to look at a plus b cubed to do something that is easier to handle. Okay, and it's simply just a plus b, right, multiplied with a plus b square. Correct? We can use what we did so far and then we can just expand from there. So it's just simply as a plus b times a square plus 2ab plus b square. It's just as simple as that. Okay, and we don't need to worry about the signs because we're just dealing with plus, so don't worry too much. Okay, so let's take a and let's expand to all these things over here. Okay, very nice. So we have our a cube, right? We have a times a square is a cube. Then a times 2ab would give me a 2a square b. Agree? Right? Then a times b square would give me a b square. Right? So this is the first term. Second one, when I multiply b with a square, is going to give me a square b. So I'll just align with this. So I'm going to get a square b over here. I'm just like writing down to a line over there. Then I have a b times this. So this is just okay, so this is just a b times that. So I'll get a 2ab square. Right? Last one, b times b square will give me a b cube. So what I'm doing, right, is like what we did in sec 2. Remember this? The rainbow method? Then for the b, I'm going to expand like this. Okay, multiply. Right, so this is what I did. So let's add them together. I'm just arranging them in terms of like terms so that it's easier to add. So I have an a cube over here. 2 of this plus 1 of this, I'm going to get a 3. Right? Then I have another 3ab square plus a b cube. Right? So at first glance, let's observe the powers of A. The powers of A, 3, 2, 1, 0. The powers of A are descending. The powers of B, they are ascending. Agree? Okay. And yeah, so far like you have these things. And then when you have cubed, you are going to get 4 terms. Right? 4 terms. When n is equals to 3. Over here, n is equals to 2, and then we get 3 terms. N plus 1 terms. Right? So like that. Okay, we have an interesting result over here. So let's go on and expand one more. Right? It's going to be tedious, fair warning over here, but it's going to be very interesting. Right? So what is a plus b to the power of 4? So it's just simply as a plus b times a plus b cubed. And let's make use of what we expanded just now. So a plus b cubed just now was a cubed plus 3a square b plus 3ab square plus a b cubed over here like this. Okay, so let's slowly expand this. Now a, I'm going to expand to 4 terms, correct? So a times a cubed would give me a power 4. So this would be give me a power 4, and I have a 3a cubed b plus a 3a square b plus an a b cubed, like this. Okay, next the b, let me expand the b now. So b times a cubed, I will have 1a cubed b, right? The next one, I'm going to get a 3a square b. Oh, sorry, a square b square. So just now was 3a square b square, correct? So the a square b square. Then the next one would be a, how many b times this, right? So this would be a 3a b cubed plus a b to the power of 4. Okay, so let's add all of this together. I've had a power 4, 4a cubed times b plus 6a square b square, right? Plus 4ab cubed plus a b to the power of 4. Okay, so this is what it looks like over here, right? Let's do the same observation again. Let's take a look at the powers of a. So we have a4, a3, a2, a1, and a0, right? So we have the descending powers of a. We have b power 0, b power 1, b power 2, b power 3, b power 4. So we have an ascending powers of b. Just nice, huh? And okay, so now I want you to observe the coefficients, right? Oh wait, before that, n is equals to 4, but we have 5 terms. 1, 2, 3, 4, 5. 5 terms. N plus 1 terms. Okay, so these are the basic observations, yeah? Okay, so with this in mind, right, I want to like ring a bell. Okay, I want to ring a bell over here. So the coefficient 1, 3, 3, 1. Even this one 1, 2, 1, and 1, 4, 6, 4, 1. Does this ring a bell? Like, does these numbers ring a bell? Actually, they do. Okay, so let me pull in the thing over here. Okay, poof. Alright, so do you see this one over here? It's actually our Pascal triangle, right? So if you see this one over here, 1, 3, 3, 1, if you check out this row, okay, if you check out this row over here, this is n equals to 0, n equals to 1, n equals to 2, n equals to 3. So the coefficient is 1, 3, 3, 1, as you can see from the Pascal triangle. So when n is equals to 4, 1, 4, 6, 4, 1, right? Cool, right? Okay, so with this in mind, so we can actually make use of the Pascal triangle to help us to expand. So we don't have to like do all this ugly work from scratch. We don't have to do that anymore, right? We can make use of a known result, right? We can make use of a known result, and we can do the necessary expansion. Okay, so with this in mind, let us come and explore. How do we hasten, or how do we make it easy to expand a plus b to the power of 5, right? So with this in mind, we don't have to do everything from scratch, right? Let us go directly from this, okay? So I will just highlight the numbers that we'll be using: 1, 5, 10, 10, 5, 1, okay? And let us try to expand and see how it goes. So remember our trend, the coefficients follow the Pascal triangle. A, the powers will go down. B, the powers will increase, right? So a power 5, I'm going to start off with, okay, let's settle the coefficient first. Okay, I'm going to do 1, 5, 10, 10, 5. Okay, maybe not enough space, so let me just squeeze a bit, squeeze a bit, and a plus 1 over here. Sure. Okay. Oh, okay, can see plus 1. Okay, then right, the next thing that I want to do is this one. I'm going to put A for everything. right? To make this faster, I'm going to put A for everything, right? And I'm going to put B for everything, if you notice. Because everything has A's and B's, right? Correct? Everything over there has A's and B's. Okay, then let's play with the powers. In our A power 4, okay? So it's A power 4, A power 3, A power 2. So the powers of A are descending. So we are going to start with power 5, power 4, power 3, power 2, power 1, power 0. Mainly working from our patterns that we've established so far. Okay, so the powers of A descending from 5 to 0. 0 included, we must include 0. Okay, now then for B, right, for B the powers are ascending, correct? So it will be B power 0, B power 1, B power 2, B power 3, B power 4, and lastly B power 5, right? So with this in mind, let us go ahead and we simplify. So 1 times B power 0 is also 1. So this is just A power 5. Then I have a 5 times A power 4B plus 10 times A cube B square plus 10 times A square B cube plus 5AB power 4, last but not least, plus a B power 5, right? Like this. Okay, cool, right? So we actually don't have to do the full expansion. We can just make use of the Pascal triangle to help us make sense of whatever that we need to expand, right? And at the end of the day, we just need to like do it simply like that. Cool, right? Okay, let's do one more example. Let's try one more example. Very exciting, right? So we don't have to do the whole as okay, we don't have to do the whole as like expansion and so on. Okay, so I'm going to like leave. Okay, where's a good place to put this? Okay, maybe I put this above me lah, so it's easier to see. Maybe I should put it below here, because I don't think I need the space below. And let me highlight a power the power 6 row, n equals to 6. Okay, yeah, so let's try. Okay, so let's try one more. So a plus b to the power of 6. All right, so let's settle the coefficients first. 1, 6, 15, 20, 15, 6, and 1. So I have a 1, 6, 15, right? 20, 15, 6, and a 1. Okay, sure, let me push that up there, and a 1. Okay, then I will have all my A's and B's, right? A and a B, 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 A and B. Now, again, following the trend, A descending power. So I'm going to start with 6, descend 5, 4, 3, 2, 1, 0. Okay, then for powers of B ascending, so we ascend 0, 1, 2, 3, 4, 5, 6. Okay, so let us, okay, tricky now, a bit tricky now. Let me like move this here. Okay, let me just move this down here. Okay, so a bit tricky now, okay. So let's take a look at this one over here. So this is just A6 plus 6A power 5B plus 15A power 4B square plus 20A cube B cube plus 15A square B power 4 plus 6AB power 5 plus a B power 6. Okay, cool, right? Very cool, right? So we don't have to do the full expansion. We don't have to do like the one by one, and by the time you do that, wow, very late. Very takes a long time. Okay, now, so the next question over here is, can we generalize this, right? Can we make it a bit more powerful so that I can do weird things like a plus b to the power of 15? Not that I need it in my life, right? But what if I want a generic result, right? Can I expand this easily? So one thinking that you may think of is that, okay, maybe I need to find the 15th row in the Pascal triangle and to do the 15 thing all together, and I can do that, but it's going to take me some time, right? So is there a faster way to do this? Definitely there is a faster way to do this. Okay, and what about, let's say if I want to look for a specific term, right, in the thing. Let's say if I want to look for this particular term in the expansion. I don't want to expand do I need to expand everything just to find one term? Technically I don't need to, correct? I will just need to as in, like, is there a shortcut to do so? Yes, there is a shortcut to do so, right? So how do we do it, right? How do we do it? Okay, let's observe whatever that's going on over here. So first, let's take a look at the trends that we see. Okay, the first thing to observe, A, the power is descending, right? The power is descending for A. The next one, the power is ascending for B, right? The power is ascending for B. And if you take a look at the powers, 4 and 2, 3 and 3, 2 and 4, they actually add up to the main power of the expansion. They add up to 6 over here. And the coefficient, where does the coefficient come from? The coefficient comes from this one, right? So what actually this one over here, remember, there's a second thing that we do this. This is actually 6 choose 1. 6 choose 0. This is 6 choose 1. This is 6 choose 2, right? This one, 6 choose 3. This one, 6 choose 4, and so on and so forth, right? So technically speaking, we can generalize the coefficients, we can generalize our terms, and we can get a general formula for this. Now, but before we introduce the formula, right, I'm going to introduce you to some notation over here. So over here, right, okay, so we have n as the power, a plus b to the power of n. So usually we put n as the power. And how do we label this thing? So over here, let's make use of our number pattern term. So we have term 1, term 2, term 3, term 4, term 5, correct? So over here, when we want to expand to powers of the sixth power, we have 7 terms, n plus 1 terms. So this will be the first term, second term, third term, fourth term, fifth term, sixth term, and the seventh term, term number 7. Okay. However, if you observe over here, these numbers 1, 2, 3, 4, 5, 6, 7, right? They are all like plus 1. You see, it's like by right should correspond to the next one, that kind of thing, right? But no choice. We have to start with first term to the 7th term. So, but there is a choice in R. So this is actually R equals to 0, R equals to 1, R equals to 2, R equals to 3, R equals to 4, R equals to 5, and R equals to 6, so that it will match with our n choose R between 0 to 6. Okay, so how do we get, how do we get this? How do we get T3? Right? How do we get T3? So T3, right, is actually 15. 15, right, is actually 6 choose 2. Do you see this? 6 choose 2. So actually this over here is 6 choose 2 of a to the power of 6 minus 2 times b squared, like this. Okay, do you see the pattern? Okay, do you see the pattern over here? 6 minus 2 give me 4, and the 2 over there. So the 4 and 2 add up to give me the 6. Okay, let's look at another one over here. Let's look at this poor guy over here. Okay, T6. T6, T6. So T6 is equals to, now this is 6 choose 5, correct? 6 choose 5 is equal to 6. So it's 6 choose 5 times a to the power of 6 minus 5 is 1, right? And we have a b to the power of 5. Agree? Agree with this? Okay, so then with this one over here, right, we can come to a formula for the general term, right? So this would be the most important formula for this, right? So the general term of the binomial expansion. So this is our binomial theorem. Okay, so general term of our binomial expansion would be equals to, okay, so this we normally will call this an r plus 1, term r plus 1. So when r is 0 is the first term, when r is 1 is the second term, and so on. So tr plus 1 is going to be equals to n choose r of a to the power of n minus r times b to the power of r, by number pattern, by recognizing the patterns. Okay, so this one over here, tr plus 1 is equals to this thing over here. So the question is it given in the formula? Yes, it is given as part of the formula for your binomial expansion. So let's quickly take a look at binomial expansion over here. SEAB AMath formula. Okay, so let's take a look at the formula sheet. Okay, the formula sheet is there on the formula sheet, right? Over here. Do you see the second one over here, binomial expansion, right? So where is the term? The term is over here. N choose r, a to the power of n minus r and b to the power r. And what is n choose r would be this one over here. Okay, so the binomial expansion, the formula for binomial expansion. They give you the full expansion, right? They give you like a list of expansion, but you notice this one over here. This will be the general term for our binomial expansion. So when we expand, we will keep using this term over here. We'll keep rolling this term. Okay, so without further ado, let us try to expand using this general term over here, right? So let's be itchy, right? And I want to try to expand a plus b to the power of 9, and let's see how that works. Okay, so how would that work would be, this would be n choose 0. I'm going to start with 0, correct, and all the way to 9. So this would be a to the power of 9 minus 0 times b to the power of 0. Okay, so for this one over here, this is the first term, and over here r is equals to 0. So r is 0, r is 0, r is 0. Do you see the position of the r? Okay, it's just an application of the formula over here. Okay, so next one, let's take a look at the second term. Okay, the second term over here. So this is going to be t2, or r is equals to 1, correct? So this will be n choose r. So n choose 1 to the power of a. Oh, sorry, not n. Now it's n is 9. Okay, so n is 9. Sorry, my bad. Okay, so n is equals to 9. So this is the important one. N equals to 9. So 9 choose 0, 9 choose 1 of a to the power of n minus r. N minus r and b to the power of r. Do you see this? Okay, can you match whatever that we're doing over here? Okay, let's look at the third term. So t3 is where r is equals to 2. So this will be plus 9 choose 3 of a to the power of 9 minus 2. 9 choose 2. Okay, r is 2. N choose r, a, n minus r, and b to the power of r. Okay, plus 9 choose 3, a to the power of n minus r, b to the power of r. Do you see the trend now? Right? Quite cool, the trend. So then let's add plus 9 choose 4, a to the power of n minus r, b to the power of r. Okay, like that. Okay, so it's really the formula plus n choose r. Now r is 5, a to the power of n minus r, b to the power of r. Right, now r is 6, so n choose r, a to the power of n minus r, b to the power of r. Okay, a few more, plus n choose r. Now r is 7, a to the power of n minus r and b to the power of r. Okay, two more, plus n choose r, a to the power of n minus r, b to the power of r. One last one, n choose r, a to the power of n minus r and b to the power of r. Okay, so the r is the running one, r0, r1, r2, r3, r4, r5, r6, the running numbers. N will be the same, power 9. Okay, and the a and b will be what we see later. Okay, so with this in mind, let us evaluate one by one. So can press your calculator. 9 choose 0 is 1. A to the power of 9 times 1. So this is going to be just A to the power of 9. Okay, plus, okay, 9 choose 1, A to the power of 8, B. Right, so this would be 9A 8 times B. Can you see? Okay, third one, N choose R. So what is this? So this is 9 choose 2. 9 choose 2, A to the power of 7, B square. Right? So this would be 36, A to the power of 7, B square. Can you see the A and B pattern now? Right? Next one, N choose 3. So 9 choose 3. Right? A to the power of 6, B to the power of 3 for this term. Okay? Next one, for this one, 9 choose 4. So 9 choose 4 is 1 to 6. A to the power of 5, B to the power of 4. Right? Double check. You see the power of A going up, going down. You see the power of B coming up. Very nicely. Okay? Next one. Let's do and 9 choose 5. 1 2 6. So 1 2 6. Okay, 1 2 6. And choose 5 of A to the power of 4, B power 5. Right? Okay, next one. 9 choose 7. So 9 choose 7 is 36. So 36 A to the power of 2, B to the power of 7. Then 9 A power 8 and B. Then plus 1 of B power 9, like that. Okay, so when we expand to the power of 9, we have 1 2 3 4 5 6 7 8 9. Missing one term. 9 8 7 6 5 4 3 3 3 3. The 84 is missing. Okay, sorry, one more term missing. So we have plus the 84 A6 B3. Yes, like this. Sorry, A3 B6. Yes. Okay, so yeah. Okay, so we should have 10 terms when we expand. Okay, so it looks a bit hideous. Okay, it looks a bit long. Okay, but it actually helps us to expand, right, nicely like this, so we don't have to do that super long like life is easy with Pascal's triangle, but we can make it easier with a generic term with the N choose R. Okay, and we just need to play with the powers as we go up and down. Okay, so I will end this video over here. We will just end it over here. Now for the next part, we are going to talk about the application of this general term. So now we are not just expanding A plus B, we may be expanding different things as A and B. Okay, and we will rely heavily on the general term to expand the following items. Okay, so I'll see you at the next video. I hope this doesn't throw you off, right? This is a very, very powerful thing that it will help us to, like, expand everything at one go. And for computing students, you can actually code this out and get all the expansion out very quickly. It will give you at one shot. So you can try to code this out and see. Okay. Alright. So like you input the N and then you come out all the expansion nicely. Wow, very, very nice. Okay. So you can try doing that as your computing project. Okay, so I'll just end it over here. I'll see you at the next one where we will tackle the exam questions and the applications of the binomial theorem. Okay, so that's all. Bye bye.